Alright, so this is just a quick guide on how to do assignment one. Uh, just kind of the overarching kind of goal of what you're going to be doing and how you would go about thinking about accomplishing that. Um, so to start with, just I'm going to go over kind of the gist of what you need to do, then I'll kind of get into the finer details of things. So to start with, let's just say you have your sequences, and then it's like these are all strings of characters, right? Strings like 1, 2, 3, and 4. Um, what you would want to do is essentially this, right? You want to build a data structure that is a map of linked lists. So the idea is you would insert an int, and that would output the head of a linked list. Uh, and this guy right here will contain all of the points where this probe shows up. So the idea, right, is that we would take, like, let's say this probe, right, he hashes to something like 2, right? That's not 2. So he hashes like to 2 or whatever. So the idea would be we would insert his location into the linked list, uh, where one of these nodes right here will have uh, 2, I guess, values, right? So you're going to have a sequence, which would be this number, and an index, which would be kind of like where your actual guy starts. So like his index is right here. Um, and then you would have a next, which just points to your next guy.
Okay, so in the video, whenever I drew the hash, or I drew kind of the structure you're supposed to make, I drew it something like this, right? Where you have your array, and then you have kind of these nodes that are all branching off of a different type. Uh, I wanted to clarify that this is not reality. This is not what your structure will really look like when you make it. What it'll actually end up looking like is something along these lines, where you've got your sort of big array, and then you're going to have your spots. Uh, but as you insert more unique probes that will create new linked lists, what will end up happening is you'll get collisions in here. And so what'll end up happening is you'll have to like add a new node here, right? But this guy and this guy don't have the same linked list associated with them. So like you'll have kind of a few nodes here, you'll have a couple nodes here, like here. Um, so kind of your table will have collisions like this, and and then coming off of each of these nodes is where you'll have your uh kind of your red nodes, I suppose, right? Where these are probes or these are locations of this probe, right? So these guys are all located in different spots, but they're the same string. Um, or they all have the same string, like I guess hashed there. This guy, on the other hand, is gonna be um, like where it's gonna represent basically a unique string. So like him and him will be different, uh, but they will have collided, so you've got a linked list. So really, what a node will end up looking like, or what one of these nodes will look like, is something like um, you'll have kind of a key, right, which is an int. Uh, and this guy will be, the value that he hashed to, and then you'll have your next, right, which is just a pointer to another node. And then you're also going to have your like location, uh, which is a pointer to a red node, right? And a red node or a location, I guess, will have kind of your sequence, like I said, your index, and then you're going to have your uh, next. And so that's kind of the difference between, so this is what I actually drew in the picture, but that's because it just looked prettier and is nice and abstract. But in reality, this is what you're making.
Um, and so everywhere that this exact value appears, and you would do a rolling hash for this, right? So you would basically just insert the hash of this sequence right here, and then this one should hash the same spot. And so all of these guys will get inserted into the same linked list in your map. Um, and so eventually you'll end up sort of with something looking like this. And these guys will all have nodes filled in too. Um, and so now that we have these numbers, right, what we can do is essentially, uh, if we didn't have the requirement for being one character off, this is it, actually. This is the whole assignment. All you would need to do is just have a for loop that goes through all of your deltas, or for all of your delta probes, right? So that's really two loops. I'm just making it one. So for all of your delta probes, you basically just go through and you just count everyone in linked list. In the linked list associated with the hash of this guy. And then once you have that amount, right, you can just basically that's just increment your false positives if the number associated with him, if his uh, essentially if the sequence that is associated with these locations is, a delta, then you can increment your, I guess, uh, or you could, yeah, increment your true positives, and then if it's, a non-delta, you can increment your false positives. Uh, Also, true positives are the same as false negatives, or you can do math to get the false negative value from your number of true positives. Uh, and then from here, um, you would just, you know, check best or check if better than best. And then that's it. That's the whole thing. But we have to deal with our one character off. So how would we deal with our one character off? The way we deal with one character off is this. Imagine that instead of hashing all of our probes of size k, we hash all of our probes of size k over 2. So this guy, right, would be k over 2, and then this one would be hashed in a different spot, right? And so what we would do is essentially we would have our sequences. We would have our sequences, right? And so you have kind of these divided probes. And so this first part kind of stays the same. So you would have your four delta probes. And what you would do is you would basically have a for loop in here that checks. So you would, I guess, get the hash right, because this guy is still of size k. This is size k over 2, but this guy is size k. So we would essentially hash the first half of him. So we'd have probe, I guess 1 and probe 2. So probe first half and probe second half. So this guy would be an int representing the hash of this number, and this guy is an int representing the hash of this number. And so essentially you have a for loop that goes through uh, the list that's associated with p first, right? And you know that everyone in that list, right, has a first half match exactly. So what you can do is just go about it the same way that you went about the first lab. And you just count this second half for off by 1 characters. So, or for up to 1 mistake, right? So we would have, if this guy was an exact match, then, we would be good. If he was 1 character off, then we'd be good. And we would increment false positives / false
so r/ true positives, if we get a match. And the other thing that we should do is we should have an int set, right? So this is the thing from lab 3, right? So you just have one of these guys, and if you find a match, you need to insert the sequence of that match into set, or your set. This is because the next thing that we're doing is we have another for loop that goes through all of your second guys, right? So now we're going to be checking this half. So everywhere that we see the second half right here, what we're going to do is we're going to check this way. And so if you find that the people, or if the k/2 characters in front of this probe, or this like hashed probe, are equal or are good, then you know that you have a match. So if the sequence that you're checking is not in your set, right? So this is a new sequence we've discovered that contains a match. Then you increment false positives and false negatives again, or true positive, or yeah, true positives again. And then now we can say if better, then adjust best. And that's kind of it, actually. So if I zoom out a little bit, we can kind of take a look at the overall picture, right? So we go through each probe right here, right? So this is just checking each series of 100 characters, or of k characters. So check this one, and then check this one, and then check this one, and so on and so forth. You just keep going over and over and over again, and then you say, all right, go forward 50 characters and go backward 50 characters, or you say, all right, let me get rid of these. Okay, so like, if you have your probe here, right, you would essentially go through all of the people who hashed to this amount right here, or this value right here, and so we would have, we have all of our other probes, and so we count them up, and we get kind of our answer on who's around. And then so I guess we would go like, and then we just go through and check all of these guys' second half, right? And then some of them will be exact matches, so like this guy and this guy might be exactly equal, so he'll check here. But because we have this int set that says that sequence 2 is already in, we know that we can not, where we know that we like don't like over add for a duplicate. And so, right, and now we would do the same thing, right? So we go through and find where our second halves are. So like if you have another probe down here that never had a match for the first one, but it does have a match for the second one, you check forward and you say, oh, look, it's a match. And so now you can increment it again. So once you have this number, you just do your math, like I said, and then you check if it's better. And if it is, then you return it. And that's kind of it. If people have questions about, or a lot of questions about how to actually make this data structure, please let me know and I can kind of go over that in more detail. But this is just kind of the overarching, like, how do assignment. So yeah, thank you for watching. Hopefully you found this at least a little helpful. And yeah, that's it.